Good morning. Chapter 9, Lesson 6 is on page 423. We're going to be doing graphing systems of linear inequalities. What a mouthful. Graphing systems of linear inequalities. So we're going to be playing with shading on two equations on one graph. And if we go slow, things will work out. We might want to use different kinds of markers to do the shading and things like that. Just go slow and things will work out. So here we go. Let's begin with number 11. 2x minus 3y is greater than 9, greater than or equal to 9. And the other equation is 2y plus x is greater than 6. So 2x minus 3y is equal to 9. 2y plus x is equal to 6. Let's make our t-charts again. X and y, we're going to use our favorite points, the x and y intercepts, so we're going to test for 0 and 0 and 0 and 0 and see what we can come up with. So in this one we have 2 times 0 is 0. So we have minus 3y is equal to 9, or y is equal to 3. Okay. I'm sorry, minus 3, because that'll give us that positive 9. And if I stick y is equal to 0, we have 2x is equal to 9, or x is equal to 9 over 2. So we've got 9 halves. On the second equation, let's make x equal to 0. So this makes this 2y is greater than 6, or 2y is equal to 6. So y is going to be a 3. And if we make, y 0, this means just x is equal to 6. So we have the points 6, 0. So let's put these on the graph and let's see what we can do with those. We have 0 minus 3. And we have 9 halves and 0. That's, I think, 4.5. So that looks something about like that. So we can draw a line. Let's use a green line, I guess. Something like that. I'm trying to remember if I could. Oh, I could unsnap the grid, so let's try that again. So I'm going to get rid of this line. I'm going to redraw it now that I've unsnapped it. Oh shoot. Let's try it again. So that's what that line looks like. Let's go over here and do this line, 0, 3 and 6, 0. So we've got 0, 3, oops, and 6, 0, so that looks like that. We should change the line color. Let's use red. So we're going to go 0, 3 and 6, 0, sort of looks like that. Now, going back to our problem, we have to test each of these things for 0, 0 to see which side we should be shading. So let's go back to this first equation. And let's stick 0, 0 in there for this one. So we have 2 times 0 minus 3 times 0. Is that going to be greater than or equal to 9? Is 0 greater than or equal to 9? I think that's false. So for this first equation, we would not be shading on this side, but we would be shading below that. Remember, this equation here was the one that said 2x minus 3y is greater than or equal to 9. And remember, this one is supposed to be a solid line, and I can't do that in this graph. So for this one, we would be shading below the graph as we tested it. So it would be there. So we tested this one for 0, 0, and it turned out to be false. Let's test the second equation, the 0, 3. That's this one. 2y plus x is greater than 6. And that one's supposed to be dashed, but I can't do that. And if we test this one for 0, 0, we have 2 times 0 plus 0. Is that greater than 6? Is 0 greater than 6? That one also turns out to be false. So instead of shading close to 0, 0 on this one, again, we would be doing exactly the same thing. And we would be shading opposite side on this side. So we would shade everything on this side. Now, where do the two intersect? Well, the two are going to intersect in this area over here on the left side. So everything that's in common, let me see if I can make this thicker, turns out to be everything over here. So there's our graph. Our graph turns out to be everything that is below 2x minus 3y is greater than 9. And everything that is above the graph 2y plus x is greater than 6. Let's try our next problem, number 21. This one has 3 pieces to it. Again, if we go slow, we'll be okay. X minus y is greater than 3. X is greater than 0. Well, that one's not so bad. And let's put x plus y is less than or equal to 5 down below. So this one we're going to make our t-chart, x and y. We have 0 and 0. So if x is 0, minus y is equal to 3, or y is equal to negative 3. If we stick y is equal to 0, this one turns out to be 3. Remember, I just made that x minus y is equal to 3. I got those 2 points. Let's go down here and make a t-chart, x and y. If x is 0 and y is 0, x and y intercept. If x is 0, y turns out to be 5. And if y is 0, x turns out to be 5. So those aren't quite so bad. This one in the middle, this x is greater than 0, is kind of interesting. It's just everything on x, any y's you want, and it's everything on quadrant number 1 and quadrant number 4. So let's plot up some of these points and see what we can do. We have 0, negative 3. We have 3 and 0, so that looks like that. I'm going to stick, I think, to solid lines. It looks something like that. Let's do this one, 0, 5 and 5, 0. So we got 0, 5, 5, 0. Looks something like that. And then we have our other graph of x is greater than 0. Well, if x is greater than 0, for that one, we have, let's try this again. If x is greater than 0, we have this. Because we're talking about the x values. X can be anything we want as long as it's bigger than 0, and it doesn't specify for the y, so y's go up and down forever and ever. So this is the graph of x greater than 0. Let's do this one over here, 0 minus 3 and 3 and 0. This was the graph of x minus y is greater than 3. And this one here is the graph of x plus y is less than or equal to 5. So let's test this one here over here for 0, 0 first. So we've got x is 0, y is 0. So we have 0 minus 0. Is that less than 3? Is 0 less than 3? I think that one turns out to be false. So if we test this one for 0, 0, this part isn't going to work. We're going to have to shade everything on, oops. I'm not sure what happened. Everything on this side. So keep in mind, we got the yellow stuff going to the right. We've got this stuff going up to the right and underneath the graph. Let's do this last one. Let's test this one for 0, 0. So we got 0 plus 0, is that less than or equal to 5? Is 0 less than or equal to 5? That one turns out to be true. So for this equation here, we have to shade 0, 0. Everything on this side of the graph is going to work for us on that one. Let's see if I can do it this way. I'm not exactly sure. So for this one, we have everything on this side has to be shaded. So what do we have that's in common? Well, let's go back and take a look at our graph. We got the yellow stuff, everything over here. We've got the red stuff, everything underneath x plus y is less than or equal to 5. And we have everything underneath x minus y is greater than 3. So what is it that we're going to have in common? I think we can sort of see the outline. Let's make this not so wide. Let's go with a blue. And we're going to outline a little bit thicker maybe. Everything that we see that's in common. So what we see in common is going to be everything in quadrant number 4. So it kind of goes up to this peak, goes into quadrant number 1 a little bit, and we shade in all this stuff over here. And we end up with everything that's in quadrant number 4. Ooh. Wow, what a pretty graph. So it wasn't so complicated. We just took it in 3 little pieces, went slowly, and everything worked out so much. Thanks again, sticking around, and we'll see everybody.